Okay, let's start with a simple question. Where do plants really get their food? I mean, we see them just sitting there growing, but what's their secret? It's definitely more than just a little dirt and water, that's for sure. So in this explainer, we're going to do just that. We're going to bust open the plant's pantry and see what's inside. You can think of the soil like this huge, fully stocked kitchen, and we're about to take a tour and check out every single shelf. All right, here's the plan. First, we'll see what's already in the soil's pantry. Then, we'll get into how we restock it. After that, we'll geek out on some smarter nutrient tech, learn how to decode those confusing fertilizer labels, and finally, we'll crack the code on the special language of nutrients. Okay, first things first. Let's dig into what nature already has on offer. The soil. I mean, that's the absolute foundation of plant nutrition, right? And it comes preloaded with its own supply of goodies. And the real MVP, the star player of this natural pantry? It's something called organic matter. Seriously, this stuff is the ultimate recycling program. It's all the broken down remains of plants and animals. And don't think of it as waste. Oh no, it's a gold mine, like a natural slow-release vitamin for the soil. But wait, there's more. Organic matter does way more than just provide food. It's kind of like the soil's architect and general contractor all in one. It fuels the tiny microbes doing all the work. It improves the whole structure so roots can actually breathe, and it acts like a giant sponge, holding onto water and nutrients. It really is the lifeblood of a healthy soil. Of course, even the best-stocked pantry can run low. And when the natural supply just isn't cutting it, well, that's when we have to step in and add nutrients back. And this, my friends, brings us to the wide world of manures and fertilizers. So you might be thinking, what's the real difference between the two? Well, let's break it down. You've got your organic manures over here. They're all natural, they release nutrients slowly, and they kind of provide a little bit of everything, but not in huge amounts. Then you've got fertilizers over here. They're man-made, super concentrated, they work fast, and they're designed to deliver very specific nutrients. It's like a balanced meal versus a targeted energy drink. And when we say organic sources, it's a really diverse group. You've got the classics like animal manures and compost, but we're also talking about more modern things like biosolids, which actually come from processed wastewater. Even just leaving crop residue in the field or planting cover crops, all of that helps restock the soil's pantry. Okay, so just throwing nutrients out there isn't the whole story. It's not enough. We have to make sure the plant can actually use them. And that is exactly where technology steps in, helping us make nutrients that are way smarter and way more efficient. So here's the big problem we're trying to fix: nitrogen. It's one of the most critical nutrients for a plant, but it's also a total escape artist. I'm serious. It can disappear through chemical reactions or just get washed away by rain. That's called leaching, long before the plant even gets a chance to grab it. So what's actually happening here? Well, it's a natural process called nitrification. It goes like this. We add nitrogen as stable ammonium. But then, these little bacteria in the soil get to work. First, they turn it into nitrate. Then, another type of bacteria turns that into nitrate. And here's the catch. That nitrate form is super mobile. It dissolves in water and can just wash right out of the soil. That's not good for the farmer's bottom line, and it's not good for the environment either. So how do we outsmart these bacteria? We use something called a nitrification inhibitor. It's brilliant. Think of it like a pause button. This chemical basically tells those bacteria to slow down, holding the nitrogen in that stable ammonium form for a lot longer. This gives the plant way more time to soak it up before it can escape. And that's not the only trick up our sleeve. There are other smart technologies too. You've got urease inhibitors. They stop nitrogen from turning into a gas and just floating away. And then there are polymer coatings. These are amazing. They're like a little plastic jacket on the fertilizer pellet that dissolves over time, releasing nutrients slowly, right when the plant needs them most. Super efficient. All right, let's get practical. Imagine we're at the garden center, staring at a wall of fertilizer bags. How do we figure out what's what? Learning to decode those labels is absolutely essential to know what you're actually buying. Let's start with nitrogen, the N in NPK. You've got options. Anhydrous ammonia, that's the strongest stuff you can get, 82% nitrogen. But it's a gas, so it has to be injected right into the soil. Then there's urea, the most common solid you'll see. And UAN is a liquid form that's super easy to handle and mix. Okay, next is phosphorus, the P. Here, the two big names are MAP and DAP. Both are solid granules. Both are packed with phosphorus. But, and this is a big but, you have to be careful with DAP. It has a bit more nitrogen, but it can actually be toxic to young seeds if you put it too close. That's a detail you really need to know. And that brings us to K for potassium. The main source here, the one you'll see most often, is potassium chloride. You'll probably hear it called potash. It's about 60% potassium and dissolves really easily in water. Okay, we're almost done decoding, but there's one last kind of weird thing we need to talk about. Why on earth do fertilizer labels use these funny-looking chemical formulas for phosphorus and potassium? I mean, if you look at a bag, you'll see P2O5 and K2O. But guess what? Those compounds aren't actually in the fertilizer. So why are they on the label? It's basically a tradition. It's a historical quirk, a chemist's shorthand that just stuck around and became the legal standard for how to report nutrients. It's a language we just have to learn to translate. And the translation is actually super simple. All you have to do is remember two numbers. To go from the actual amount of phosphorus to what's on the label, you multiply by 2.29. And for potassium, you multiply by 1.20. That's it. Let's try an example so you can see it in action. So let's say you have a fertilizer and you know for a fact that it contains 20% of pure elemental phosphorus. What would the label on that bag actually say? You just pull out your calculator. You take that 20%, you multiply it by our magic number, 2.29, and you get 45.8. We'll just round that up to 46. So the bag would be sold as a 0.460 fertilizer. See? You've just cracked the code. So we've got on a whole journey today. We've peeked inside the plant's pantry, from what's there naturally to the high-tech fertilizers we use to restock it. We've learned how to manage it and even how to read the labels. But all this progress leaves us with one pretty big question. As we master the science of creating the perfect diet for our crops, are we sure that the recipe we're using is one that's actually sustainable for the planet in the long run?